Hybridization is one of those general chemistry and organic chemistry crossover topics that the MCAT loves. It's not just about naming orbitals, it's about understanding how molecular geometry, bond strength, and reactivity all tie together. If you've ever looked at a molecule and thought, wait, why is that carbon trigonal planar instead of tetrahedral? Hybridization explains it all. Once you master this concept, predicting bond types, shapes, and resonance patterns becomes second nature. Hybridization, the orbital remix. Hybridization happens when atomic orbitals mix to form new hybrid orbitals that are better suited for bonding. It's the atom's way of reorganizing itself to make stronger, more stable covalent bonds. These hybrid orbitals determine everything: shape, angles, and even how the molecule reacts. sp3 hybridization, 4 bonds, tetrahedral shape. Here, 1s and 3p orbitals mix to create 4 sp3 hybrid orbitals. They arrange themselves tetrahedrally, 109.5 degrees apart, the perfect spacing for minimal repulsion. You'll see this in methane, CH4, and other single-bonded, sigma-only molecules. Rule of thumb: no pi bonds, sp3 hybridized. sp2 hybridization, 1 double bond, planar shape. Now, 1s and 2p orbitals mix to form 3 sp2 hybrid orbitals. They arrange in a trigonal planar geometry with 120-degree bond angles. The remaining unhybridized p orbital forms a pi bond. Think ethene, C2H4, 1 sigma bond, 1 pi bond per double bond. sp hybridization, triple bond, linear shape. For sp hybridization, 1s and 1p orbital combine, forming 2 sp orbitals aligned 180 degrees apart, a linear geometry. The 2 leftover p orbitals form 2 pi bonds, which make a triple bond. Example: ethine, C2H2, strong, linear, and packed with electron density. Sigma and pi bonds, the backbone of bonding. Sigma bonds are formed from head-on overlap. They're the first bonds formed and the strongest. Pi bonds form from sideways overlap of unhybridized p orbitals. They add rigidity but are weaker than sigma bonds. Every double bond equals 1 sigma plus 1 pi. Every triple bond equals 1 sigma plus 2 pi. Geometry and bonding patterns. What hybridization tells you. Hybridization directly predicts molecular geometry. sp3, tetrahedral or trigonal pyramidal if one lone pair. sp2, trigonal planar, sp, linear. Once you know hybridization, you instantly know the molecule's shape and angles. No guesswork. Resonance, the hybridization wildcard. Some molecules, like benzene, can't be pinned down to one Lewis structure. That's resonance. Electrons delocalize across conjugated systems, blurring the lines between single and double bonds. Hybridization explains this too. Resonance keeps p orbitals overlapping, stabilizing the molecule. If you can look at a molecule and identify its hybridization, you've unlocked one of the biggest shortcuts for the MCAT. You'll instantly know geometry, bonding, and electron distribution, all from a single glance. With that said, here are just a few of our student success stories. Students who mastered these concepts, boosted their scores, and got into medical school. If you're studying for the MCAT, click the link below to get started with your own prep. We help students reach a 515 plus on the MCAT, and we'd love to do the same for you. And don't forget, subscribe to our channel for more MCAT breakdowns like this, and follow us on Instagram for extra tips and resources.